Okay, lecture 1, remote sensing and digital image processing. Yes, will cover the relevant contents of the chapter 1 and chapter 2 in this textbook. Okay, and after this course, after the class, I will send you the PDF, the textbook. Okay, the PDF format version to you by WeChat. You can read it. Yeah. And this is the outline for the lecture 1. First, we will introduce the remote sensing process, and second is the data model, and the third is imaging capability. Okay, 4 data collection, and the fifth the digital image processing, and the last summary what we introduced today. Okay. So first we will introduce what is remote sensing. What is remote sensing? Okay. Remote sensing is remote sensing is used for obtaining information about a target through the analysis of data acquired from a target from the target at a distance. So it is sensing, but by from the remote. Okay, so this is the name. A sensor, yes, all aboard. Slide, yeah, the red point. Okay, a sensor on board satellite or airplane can record radiometric information from a target on the ground. When the solar light reaches to the target, such as the canopy of a tree or the building, the target may reflect some fraction of solar energy back to the sensor. So sensor records this kind of radiance energy called spectral information as an image. Looks like this image. This is record radiance energy. Yes, radiance. Then the image information can be transmitted to ground to input computer data processing systems. Yes, to process and analyze the image data. So the output from the computer data processing system, something looks like that. Yes, this is different colors that represents different size, land use or land cover types. Yeah. This is called the semantic maps. Okay. So use this information, we can find find this area of the land use, land cover, yes, change. So can use remote sensing images can be used to detect its change. Yeah. The remote digital remote sensing is you see this is sensor system on board the analog to digital conversion and calibration. Yes, to the signal. And this is and to collect it and the information and by the data per processing, then can be changed to information about its distribution. Okay, by visual or digital information exchange, extraction. Okay, this is and this is more detail about the processing. Yes, sensing process. The first is how what is the problem? What you want to do? Yes, so statement of the problem. Then you should collect the data. So the data may be in situ measurements and collateral data, and then is a lot of remote sensing images like passive, analog or passive digital, and the active, yeah, radar data, something like that. And change this data to information. So this is our main point, is just on the digital image processing. And after that, the image, this information can be uh, can be presented. Yeah, with this yeah, this one. Okay, so this is a process, and this is how the electromagnetic radiation. Yes, is the term remote sensing has become most commonly used in connection with electromagnetic techniques of information acquisition. Information is acquired in form of electromagnetic radiation. Or electromagnetic radiation has fundamental properties and behaves in predictable ways according to the basics of wave theory. Electromagnetic radiation. So we just say the EMR, simple say EMR, consists of an electrical field, E, electrical field, E, yeah, the purple, the red, the yellow, yellow, electrical field, which varies in magnitude in direction perpendicular to the direction in which the radiation is traveling, and magnetic field M, the purple color, oriented at right angles to electrical electromagnetic oriented at right angles to the electrical field. So both these fields travel at a speed of light c, speed. So this is we to the, and the lambda is wavelength, and f lambda is wavelength, and f is frequency. Frequency. So okay. So the electromagnetic spectrum. This is a picture for the spectrum. Yeah, and you see this is from the short wave to the long wave. Yeah. So here is the gamma rays, X rays, ultraviolet. Yeah. And this is we use the most, is the visible. We can see by my eyes. Yes, our eyes is visible, visible, and near infrared, short wave infrared, medium infrared, thermal infrared, microwave, radio. Yeah, such as this is the micro radar. Yeah, also remote sensing use this from here to here. Yeah, remote sensing also use these waves. Okay, this is used by radio and television, FM radio and AM radio. Yeah. Okay. So, and the wave, the unit of the wave is sometimes use UM, or NM or nanometer or UM. So this is point 4 from point 4 to the point 7. Point 7 is visible, right? Analysis relies upon measurement of EM energy reflected or emitted from the objects of interest on the surface of the Earth. Solar energy absorbed by the atmosphere and Earth's surface is radiated to sensor, which is referred to as emission. Okay, so reflected or emitted, yeah, by the target on the Earth. So one is looking at the physical nature of special attributed features while measuring the EM energy. So this is the principle. Yes, why the emoter, the sensor can receive the energy from the Earth. Okay. And the second, we will introduce the remote sensing data model. And here we will introduce the format of the remote sensing, how the record its information. The format is used in raster. You see, this is the raster image, raster 1, raster or pixel. It is record on in row and column. Yes, each pixel. Yeah, so raster or pixel. Yeah, here. And record from maybe from here. This is 0, and this is x-axis and y-axis record. And the pixel means picture element. So each pixel, each square has the element, so it is was recorded. So pixel value equals to the electromagnetic energy recorded by sensor approximately at each pixel location. Okay. So here is about pixel. You see, this is the yellow. This is the incident energy. As it's this energy is equals to the red one reflected energy, and plus absorbed energy, and plus transmitted energy. So this all three equals to incident energy. And you see, there's a yellow one, the blue and the red, and some energy is absorbed by buildings or trees. Yes, on the ground, on the Earth's surface. Yeah, some is absorbed. Yeah. And what is a digital image? This is one of the digital image you see. It's gray, white, black and white, no color. Yes, just gray. This is the image. You see, you enlarge this here, this area. You can see it's a lot of pixel. This is each one is a pixel. So each one is record a digital number. Yeah, digital number. You see here, this is 70, 53, 41. It's the digital number. What's the digital number means? It means the image, the energy. Yeah, the energy, EM energy. So maybe now, yes, here you see the number is the lower. So maybe we can use the color is black, and some here more than 100 here is maybe the gray. Okay, the gray and means the number, this number is or the white, the digit number larger, and this is lower. You use a different gray, white, or black. Yes, represent this digital number. Yeah. Okay. The grayscale. Grayscale. Okay. This is what our digital image can see. Yeah, this number, digital number. And sometimes the remote sensing image we record is not just a lot of bands. Say so. There is several images set here. The four image. You see four bands. From then you can see the first band. First band is the pixel number, the digital number in each pixel. So, for example, at the column 4 and the row 4, you can see this pixel, the value is 24. So we can record BV. 441 equals to 24. This 44 is row and the column, and this one means the band 1, band 2, band 3, band 4. Because this band is recorded means from different waves record, and this is grayscale. Okay, associated with grayscale. Okay. And we also can use this different band. Yes, different band. The gray. Okay, all the gray image, but we can use the computer screen can use give its name or display in RGB side. For example, we can the near infrared band give its the color, this color, and the red band, this color, and the green band give and the green, yes, and we can overlay to then we can see the color, So not just for the gray, white, black image. You can see the color image. Use the different band to in RGB displayed in the computer screen. Okay, so and next we will introduce the remote sensing capability. Here we introduce 4 resolutions. Okay, namely spectral resolution. So what is the spectral resolution? And the second is spatial resolution. Third, temporal and the fourth is the radiometric resolution. So we'll introduce step by step. And spectral resolution means the number and dimension of specific wavelength intervals. In the electromagnetic spectrum, to which a remote sensing instrument is insensitive. You see here, it's for example, say the Landsat multispectral scanner, simply called MSS. This image you see can record 4 bands. The green band is its wavelength from 0.5 to 0.6. The red is from here to here, and the near infrared, and near infrared, NIR, different, And this is for the multispectral and the optical, and this is for the positive system, ADA, use there more narrower. You see this is green. You see here, more narrower. Blue, green, red, near infrared, So and here the spectral resolution is the maximum. So precise band pass magnet of a detector based on 4 widths and half maximum criteria. So this is the spectral resolution. Is say here from here just this is say 4 widths and half maximum FWHM. So is from 0.7 to 0.8 here. FWHM is called the spectral resolution. Okay. And this is for MSS image, and this is for the ADAR. Yes, for this data. This is very old. I never used this. This is digital frame camera. So I never used this data. Okay, before. And this is also 4 bands: blue band, green band, red band, and near infrared band. So every band have its the range of the waves. You see the range. Okay, so you can see this is 4 widths at high maximum is spectral resolution. Means the spectral resolution. And for the multispectral image, say a TM, Landsat TM, and say okay, here is the 1, 2, 3, 4 bands, 4 bands, and you see you can record every band. It's wide. Okay, this is very wide. Okay, and you see this is the hyperspectral resolution. Hyperspectral images. You see from the 400 to 900 nanometer, there are 50 bands. 50 bands. You see a lot of bands. So it's every band is very narrow. So maybe use this image can record the ground information in more detail. So this is very wide, so you cannot find it in detail because it is wide. The image make not so clear as yes. Okay, so this can find more detail. Okay, this is the band, the spectral. So we can say the average, yes, the spectral resolution is very high, but for TM, yes, it's lower because it is multispectral. This is high spectral. Yeah. Okay. And after we introduce the spectral resolution, then we will introduce spatial resolution. What is the spatial resolution? I think this is simple, more simple. You see, this is an image, same area, but different spatial resolution images. You see, this is special. You see, this is can see very clearly. Say this is the trees, roads, and some buildings, all the ground. Yeah, they're very clear, and you also can see the shadow of the sun shadow. You see the building. Okay, the shadow. So very clearly, very clearly. But with the special resolution, yes, yes, from the 0.5 to 2 meter and to 8 meter, we can, yeah, the lost a lot of cannot see, yeah. You see here you can see also, yeah, 5 meter plus multiply 5 meter, but here you cannot see, yeah. Okay, and there here just see the pixel pixel, but what it is now I don't know. From use our eyes we don't know. Maybe use the computer and some training samples we can classify it. Maybe find some information. Okay, but we use our eyes, we cannot know what it is. Okay, just see that this number here is lower and here is large. Yes, just for this. So the spatial resolution is the measure of the smallest angular or linear separation between two objects that can be resolved by sensor. By sensor, the pixel size. Yes, pixel size. This is spatial resolution. This is Venus urban area. This is you see this is the 4 meter for Econos. It's from America. Yes, platform. Digital group. This is a company. Yes. So its spatial resolution is high, so we can see there's some buildings. This is large buildings, and this is maybe water, some buildings, and other, or maybe I don't know. This color. Don't know what it is. Okay. With spatial resolution, it decreased. You see, you can see just some color, but don't know what it is. You see, here this is a Hyperion, 30 meter, 30 meter. We don't know what it is. I just see this color, the pixel, the color. But I don't know what it is. Okay. And the third resolution is called temporal. Temporal resolution means how often the sensor records image of a particular area or location on the Earth's surface. For example, NOAA AVHR series twice daily can collect data twice daily, morning, afternoon, so very frequently. And EOS mode is now once daily. Okay, it's very good. Like Landsat, we use the very often Landsat. Yes, because it is a lot of Landsat series, so we use the lot of. And every 16 days. Okay, so can yes, collect an image. So 16 days. Okay, sport, yes, sport. It's high resolution visible. 26 days. but locally flexible 2 or 3 days. This is oblique view, not the vertical view. This is vertical. The want 26 days. Okay, and just e-commerce digital global. Yes, 6 days. 6 days maximum. 6 days can collect the image. And a quick word. Yes, less than 3 days. And say this image GEOES means geostationary operational environmental settlement. Every 15 minutes we can obtain one image because it is its orbit is very high on the Earth, so can almost very stationary, geostationary, can see the whole Earth, whole the ground of the Earth. So because it's very high, yeah, the orbit is very high near the. So it's every 50 minutes, but its spatial resolution is very lower. Okay. This image is mostly used for weather forecast. Yeah, weather forecasting. So we want high frequency image. Yes, to detect the atmosphere or the sea environment, such as gears. We say the Landsat. There are NASA from America. So Landsat have Landsat 1, 2, 3, 4 to Landsat 8. So lot of. Now is used is Landsat 5, Landsat 7, and Landsat 8. The others has it cannot be used. Yeah. Still on the orbit only Landsat 5, Landsat 7, and Landsat 8. Okay, so use the ETM, and the Landsat 8 is OLR. These images can be used now. And they collected maybe from the 1980s, from the 1980s to today. So this image is the best because it can detect long history. Yes, about more than 40 years. The change about the resource or the environment is changed, or the urban expand, or the how the a farmland. Yes, how it's changed. Yeah, more than 40 years. Okay, so this is some represent data acquisition. Yeah, say the Landsat series, the special is 16 days. Okay, but here if you collect one image, after 60, can you sure you can collect an image? No, I'm not sure, because sometimes here, if it is the crowd or other noisy, maybe because it's an optical optical image, so can be impacted by the crowded or the other atmosphere. Yeah, so maybe the quality, yes, cannot. Yeah, sometimes we can. Yeah, sometimes. But for the areas that with a lot of raining or the cloudy area, so maybe this is not a good data source. maybe use radar, radar, because radar can penetrate the cloud and to collect the energy from the ground. Okay, this is Landsat, this temporal resolution, and the last resolution is the radiometric resolution. Radiometric resolution is means the sensitivity of remote sensing detectors to differences in signal strength as it records the radiant flux. Okay, so here you see 8-bit can record yes, the value is from 0 to 255. So you collect, you can differentiate say 256 different colors. Okay, so 8-bit. So what is the 8-bit image set? Here before we can use the Landsat TM. TM is 8-bit. So the color for the TM you can use 256. But for MSS only 6-bit. So only use the 6 how much? 100, more than 100, colors. And for the here Landsat, so for the OLI, it's 12-bit, 12-bit. So can yes, it's can differentiate more information because it's the difference. Yes, more sensitive to the differences is 12-bit OLI. But Landsat TM is 8-bit TM. MSS is 6-bit. So then we have summary about the remote sensor resolution. The first is the spatial. Spatial means the size of the field of view. 1 pixel. 1 pixel. This is the one. Say such as here is a 10 meter multiplied 10 meter. This is called spatial resolution. And the spectral resolution means the number and the size spectral regions. The sensor records data in blue, such as blue, green, red, near infrared, thermal infrared, microwave, such as that. Yes, this is called spectral resolution. And the temporal is means how often the sensor acquires data. For example, Landsat every 16 days we can collect the data. Okay, and the radiometric resolution means the sensitivity of detecting small differences in electromagnetic energy. So here we see the Landsat. Yes, you see MS, TM, ETM plus OLI. In the original, they were signed at the end of 2020. They were America will launch the Landsat 9, but until today, no information about the Landsat 9. So now on the orbit is the Landsat 8. Is the current newest. So don't know the Landsat 9 when it will be launched. Okay, and so and the fourth is remote sensing data plan. We have a wrist, okay? Have a wrist.
OK 了，OK 老师。
OK，OK。
Thank you。
好的。要上那个网课。